in this problem, we're going to work the integral of the inverse function of some function that we assume that it does exist. Here, f2 minus 1, it means the inverse function of some function f. We assume that we have all the conditions that we need. We assume that f is differentiable on this interval, f of a, f of b, and f is continuous and exists and differentiable on the interval a, b. We want to find a simpler expression or a formula for I, the integral of f inverse between f of a and f of b. This one appears a lot in some competitions and in some exams, and we have to get rid of it and have it in our mind. The key to solve this problem is a change of variable. Okay, so if we let y equals the inverse function of f. Okay, so let y equals the inverse function of f at x. Okay, in this case, when x is f of a, y is going to be a, and when x is f of b, y is going to be b. Therefore, we have I is becoming the integral between a and b of y, and we need to compute dx. To compute dx, we're going to integrate. Okay, so here we see that we if we do integrate, dy is going to be f inverse of x prime times dx. But what do we know about this one? It's going to be 1 over f prime f inverse, okay, of f of x times dx. And this is just 1 over f prime of y dx. Therefore, dx is just f prime of y dy. If we plug it here, we're going to get I is going to be the integral between a and b of y f prime of y dy. Okay, now we don't have the inverse function here anymore, but we have this one, and we need to integrate this one. Okay, you can think of y as x because this is just a dummy variable. Okay, let's integrate this one using some integration by part. Okay, let u equals y and v prime equals f. This gives us that the integral of uv prime is uv minus uv prime. Okay, I forgot the bounds here, or the upper limit and the lower limit, but let's do that. Between a and b, between a and b, between a and b. Once I do that, I have u is y, and v is f prime. Sorry, v prime is f prime. V is just f. So f between a and b minus the integral between a and b of u, in this case u prime. So u prime times v. I made a mistake. So uv prime is going to be uv minus u prime v. U prime is going to be 1, and v is going to be f of y dy. All right, be careful, I made a mistake here. uv prime is uv minus u prime times v. U is y, and v is just the integral, primitive of v, which is f, between a and b, minus u prime, which is 1, times v. V is just f. Now, we can evaluate. We're going to get b f of b minus a f of a, minus the integral between a and b of f. Here, okay, let me write it down and we come back to it. So, therefore, the integral between f of a and f of b of f of inverse, f inverse of x dx is giving me this value. Here, dy is just a dummy variable. I can change it to make it x, so the integral between f of a and f of b of f inverse dx is going to be b f of b minus a f of a minus the integral between a and b of f of x dx. The y here just a dummy variable. So that's what it means. So if you want to integrate an inverse function, all you need to know is the f, is its original function. Okay? And sometimes this is written another way. In some problems, it's going to be the integral between a and b of f of x dx plus the integral between a and b of f inverse of x dx is going to be b f of b minus a f of a. We can give some